Have you ever stood near a machine and felt strong vibrations, but the vibration report says within limits? Or you hear terms like 0.3G, 1.5G, 3G, and wonder, backhand index pointing right, what does G value really mean? Backhand index pointing right, when is vibration dangerous? Backhand index pointing right, and how can we practically reduce it in plants? Today on Simple GAN, we'll break down G value and vibration reduction, simple explanation, real-life examples, and proven maintenance strategies. Let's begin. Let's start with the basics. G value represents vibration acceleration relative to gravity. 1G equals 9.81 meters per second squared. So if a machine vibrates at 0.5 G, it means the vibration acceleration is half of gravity. Magnifying glass tilted left, why use G instead of millimeters per second? Velocity good for overall machine condition. Acceleration best for high-frequency faults like bearing defects, gear mesh problems, looseness, cavitation. Backhand index pointing right. That's why G value is critical for early fault detection. Now let's understand what different G values mean in practice. Bar chart general guidelines G value. 0 to 0.2 G excellent, 0.2 to 0.5 G acceptable, 0.5 to 1 G alert, 1 to 2.0 G warning, above 2.0 G critical. Warning note, limits vary with asterisk machine type, speed, and standards. Factory plan example, motor D bearing 0.25 G white heavy checkmark, pump NDE bearing 1.4 G warning. Backhand index pointing right indicates early bearing damage or lubrication issue. High G value means high acceleration, and that's bad news. Police car light effects of high vibration acceleration, accelerated bearing fatigue, cracks in foundation, loosening of bolts, shaft misalignment, seal failures, noise and energy loss. Chart decreasing result, higher maintenance cost plus unplanned breakdowns. Before reducing vibration, we must find a cause. Red circle common reasons, bearing defects, poor lubrication or wrong grease, misalignment, rotor unbalance, mechanical looseness, gear wear, cavitation in pumps, weak foundation.
Direct hit rule. Never treat vibration, treat the root cause.
White heavy checkmark 1. Precision shaft alignment. Laser alignment preferred. Reduces vibration by 30 to 50%. Extends bearing life. White heavy checkmark 2. Dynamic balancing. Correct rotor unbalance, especially for fans, blowers, rotors. Even 10 grams imbalance can raise G value drastically. White heavy checkmark 3. Proper lubrication. Right grease, right quantity, right interval. Oil drum over-greasing equals as bad as under-greasing. White heavy checkmark 4. Bearing quality and installation. Avoid hammering, use induction heaters, correct clearance. White heavy checkmark 5. Tightening and structural rigidity. Torque bolts correctly, fix soft foot, strengthen base plates. White heavy checkmark 6. Isolation and damping. Anti-vibration pads, rubber mounts, spring isolators, grouting under base frame. The smartest plants don't wait for failure. Bar chart best practices. Trend G value over time. Compare DE versus NDE. Combine. Velocity, acceleration, FFT spectrum, set alarm and trip levels. Crystal ball, this is the heart of predictive maintenance. High velocity, structural problem. High acceleration, bearing, or high frequency fault. Pushpin, always analyze both together. So remember, G value is not just a number. It's an early warning signal that saves machines, money, and manpower. Backhand index pointing down if this video helped you. Thumbs up like the video, bell, subscribe to Simple GAN speech balloon comment. Which machine vibration problem do you face most? Engineering concepts, explained simply. This is Simple GAN. See you in the next video.